Hello students, and welcome back to another algebra video. You know what to do. Pause the video, try these problems in your notes. They are a review from the last lesson we had. Then unpause the video to do them with me. Okay, problem asks us to find the domain and range. Remember, the domain means all of our x values, and the range means all of our y values. So our first graph is just a series of points, and our second graph is a smooth curve connected by 2 points. Okay, so let's look at the first graph first, and let's break these points down into their x and y components. So the top right point is x is 2, y is 4. Our second point is x is 1 and y is 2. The bottommost point is at 0, 0. It's right there at the origin, hasn't moved at all. Our fourth point is at -1, 2. And the last point in the top left is at -2, +4. Okay, there we go. So now our domain is going to be all of the x values. So -2, -1, 0, +1, and +2. There you go, all the x values. The range is going to be all of the y values. So remember, domain is the x, range is the y. So we have 4, 2, 0. Oh, 2's already on our list, and 4 is already on our list. So our range is 4, 2, and 0. Now I know what you're thinking. Wait a minute. Shouldn't the range have the same amount of numbers in it as our domain? Doesn't matter. Doesn't matter. As long as every input, every x value has one y value, that's what matters. Okay, now let's move on to the second graph, and I'm going to change colors. When we look at the domain, or our x values, we're looking along the x-axis. So the graph ends at 1. So the smallest number x can be is 1. And the biggest number x can be, the graph stops at 5. Graph stops at 5. So our domain is x is between 1 and 5. Now I'll go back to yellow for the range. For the range, I'm going to look at my y-axis, because the range is all of my y values. Now the smallest number, the bottom of the graph, is at 0. So y has to be bigger than 0. And where is the top of our graph? 4. The graph is in between 0 and 4. So y is bigger than or equal to 0 and less than or equal to 4. And there you are. Wonderful. Nice review from yesterday, but let's move on to what we have for today. So yesterday we looked at functions in general. In general, what is a function? Today we're going to zoom in on linear functions. So we're still talking about functions, but we're talking about functions that are linear. So, your learning target for today is that you know what is a linear function. And how will you know if you know what a linear function is? Well, you can identify linear functions using graphs, tables, and equations. So you can identify linear functions. You can look at a graph and say, that's a linear function. You can look at a table and say, ooh, that's not a linear function. And you can look at an equation and decide, is this linear? Is this not linear? And so on and so forth. So, first, you need to know what is a linear function. Now, pretty simple, pretty straightforward. A linear function is a function whose graph is a non-vertical line. Yup, it's a line. And you can see right in the word linear, it says line R. Like linear, the word line is right inside of the word. So if we are looking for a linear function, we're looking for a function whose graph is a line. Not a vertical line, and we're going to talk more about why vertical lines aren't functions. Well, you know why a vertical line isn't a function, because it doesn't pass the vertical line test. It is a vertical line, but we're going to talk more about why it's not a function in the future. So any line, so the yellow line that I'm drawing, that's a linear function, that's a linear function, that's a linear function, that's a linear function. Any line, literally any line, is a linear function. And a nonlinear function is a function that does not have a constant rate of change. That's a graph that does not have a consistent slope. We're going to talk more about slope in future videos. And whose graph is not a line. So basically, if your graph is curvy, it's not linear. Okay, cool. There you have it. There's the learning target. Almost there. We just need to focus on the success criteria. So, example 1. Identify linear functions using, graphs. This should say graphs. Using graphs. So, does the graph represent a linear or non-linear function? And explain. Let me switch colors here. So, part A. This is, what do you think? Is it linear or non-linear? Is it a line? No. So this is non-linear because its graph is not a line. You also could have said this is non-linear because the graph is curvy. Anything like that would have worked. Okay. Part A, this graph is, what do you think? Is it linear or non-linear? Is this a line? Yes. So this graph is linear because it is a line. There you go. Yeah. So, and you might think, wow, this is so simple, but this is really important because as we continue chapter 3, we're going to continue talking about linear functions, and you want to be able to know from a graph, is this linear or not? Do I care about this? Is this what I want it to be? So, let's check and see if we were correct. Graph is not a line, so it's non-linear. The graph is a line, so it's linear. Bada bing, bada boom. Moving on. Example 2. Identifying linear functions using tables. So remember, our success criteria said you would be able to identify linear functions using graphs, tables, and equations. So we talked about graphs, now we're going to talk about tables. And so remember, I briefly mentioned slope. that a nonlinear function was a function that does not have a constant rate of change. So when you think about this slope, what it is every time we move x a certain amount, we also move y a certain amount. So if I move x to the right 2, I'm also moving y up 2. Now, that might be a little confusing right now, and we're going to talk more about slope in a future video. But for now, what you need to know is if we have a linear function, I should be able to add or subtract the same number repeatedly. Now let me show you what that means. Let's zoom in on part A. 3, and let me get a different color too. 3 plus or minus what gives me 6? Well, 3 plus 3 gives me 6. Okay. And how do I get from 6 to 9? Well, 6 plus 3 gives me 9. Okay. And if I add 3 to 9, I get 12. So all along the top row, I see plus 3, plus 3, plus 3. Okay. And if I'm looking at the y, let me see. 36 minus 6 gives me 30. Minus 6 gives me 24. And, this one's a little bit harder. 24, minus 6 gives me 18. Awesome. So, notice how I am adding the same number on top. Plus 3, plus 3, plus 3. I'm adding the same number. And for my outputs on the bottom, my y values, I am subtracting the same number every time. Minus 6, minus 6, minus 6. So, as long as I am adding or subtracting the same number across the inputs and adding or subtracting the same number along the outputs, we have a linear function. And the reason for this is if we graphed these points, 3, 36, 6, 30, right? Of course, this is not a beautiful graph. But if we graphed these points, 9, 12, we would see that as I am going down 6, I am going plus 3. And in order for me to have a line, right, a graph that is a line, I need to be moving down in the exact same way. I need to be going down 6 each time. If I all of a sudden decide I'm going to go down 10 and write 3, well, that doesn't work. Now the point is here. And if I tried to connect these points, oh, wait a minute, that's not a line anymore. So that's why I need to be adding and subtracting a consistent amount each time. Now, notice that these numbers do not need to be the same. I have plus 3, minus 6. You don't need plus 3 every time. It does not need to be plus and minus every time. We could have had minus 3 plus 6. We can have minus 2, minus 4. They can both be positive. They can both be negative. One can be positive. One can be negative. It doesn't matter. What does matter is that it is the same number. If I'm subtracting 2 on the top, I'm subtracting 2 every time. And if I'm adding 4 on the bottom, I'm adding 4 every time. That's what matters. Okay. And remember, if you want to see more examples, you can always go to the ebook in Big Ideas and see all the tutorials there. All right. We need to answer their question. We need to say, yes, this is linear because we add or subtract the same number. This means number, not just hashtag. The same number every time. Okay, let's move on to part B. So, 1 plus 2 gives me 3. 3 plus 2 gives me 5. And 5 plus 2 gives me 7. Yay! Okay, every single one of these is plus 2. So that looks good so far. That's good. We just need to make sure that the bottom is also consistent. So, 2 plus 7 gives me 9. Okay. And 9 plus 11 gives me 20. And 20 plus 15 gives me 35. Oh, 7, 11, and 15 are not the same number. So, this is nonlinear because we don't add the same number on the bottom. So there you have it. There you have it. And remember, the reason we need to add the same thing every time is for this reason. The graph we talked about. I have to move down and to the right, or up to the right, up to the left, whatever, the same amount every time. Otherwise, we're going to end up with a weird, curvy situation. We're not going to have a perfectly straight line, which is what we want. If we have a linear function, we need a perfectly straight line, just like we talked about in the first example. Okay, let's check and see if we were right. Plus 3 plus 3 plus 3 minus 6 minus 6 minus 6. The function is linear because we have a constant rate of change, or the rate of change is constant. That's the slope that we're going to talk more about in a future video. Okay, and plus 2 plus 2 plus 2 plus 7 plus 11 plus 15. The rate of change is not constant. Y increases by different amounts, so it's nonlinear. That's what we said. So we're good. We're good to go. All right. Last example for today is about identifying linear functions using equations. So, just by looking at an equation, is it linear or not? Well, so linear functions need to look like this. Y equals mx plus b. We're going to talk much more about y equals mx plus b in a future video. This was my favorite equation for a very, very long time. Just ask my middle school math teacher, and she will tell you that I loved y equals mx plus b. And that's because it's very important. We're going to use y equals mx plus b in future videos, future lessons, future chapters as well. So, what this is, y equals mx plus b, any line, the equation of any line can be written this way. Y equals some number times x plus some number. M and b are numbers. So, notice how if I look at the very last example here, if I solve for y, and I get y by itself, so I add y to both sides because that moves it to the other side of the equation, I get x squared equals y. Is this in the form y equals mx plus b? So I can rewrite this as y equals x squared. That's okay, I just switched sides. Y equals x squared. Well, no, if I had y equals x, that would be okay, because m is 1 and b is 0, so I have y equals 1x plus 0. That's fine. But y equals x squared, no, I don't want exponents. I do not want exponents in my linear functions. So, we say, this is nonlinear because linear functions don't have exponents. Linear functions don't have exponents. Okay. Now, let's go back and look at the first equation, y equals 3.8. Can this be written in the form y equals mx plus b? Yes, it can. This is like y equals 0x plus 3.8. Because what is 0 times x? Well, it's 0. So, we say, yes, this is linear because it can be written in y equals mx plus b. I'm going to stay down here while you finish writing that. And then I'm going to come back up. If I can write an equation in the form y equals mx plus b, it is linear. Now there are other forms of lines besides y equals mx plus b. We're going to learn about those later. Y equals mx plus b is the best one. It's the best one. Okay. All right. Now let's look at the second one. Y equals the square root of x. Can that be written in the form y equals mx plus b? No, it has a square root. We don't have a square root. So we write this is, and actually let me get a different color so that they're not blending in here. This is nonlinear because linear functions don't have square roots. Can't have square roots. Okay. All right. And let's move on to the next one. Y equals 3 to the power of x. Well, wait a minute. We already said linear functions don't have exponents. So this, y equals 3 to the x, cannot be written in the form y equals mx plus b. So, and I'll erase this now. This is nonlinear because linear functions don't have exponents. Okay, moving on. And actually, I'll keep y equals mx plus b down here at the bottom because it's important and I like it. Okay, all right. Y equals 2 divided by x. Okay, so we don't have any exponents, so that's a good sign. But x is in the bottom of the denominator. So for me to rewrite it in the form y equals mx plus b, here x isn't in the denominator, it's in the numerator. So this is also nonlinear because linear functions don't have x in the denominator. They don't have x on the bottom of a fraction. So this is nonlinear. All right, and last one, y equals 6x minus 1. Can this be rewritten in the form y equals mx plus b? What do you think? Well, let's see. If I distribute this 6, I do my distribution rainbows, as I call them. We have y equals 6 times x is 6x, and 6 times negative 1 is negative 6. Oh, hey! Look at that! Y equals mx plus b. M is 6, and b is negative 6. Awesome! So yes, this is linear because it can be written in the form y equals mx plus b. Yay! Wonderful. Okay, cool. Let's check and see if we were correct. Which of the following equations represent linear functions? Y equals 3.8 and y equals 6x minus 1. You cannot rewrite these equations in the form y equals mx plus b, so these equations cannot represent linear functions. Hey, that's what we said. So we were correct, and we are good. Awesome. Okay, so in summary, we have different ways to represent functions. So we have graphs, we have inputs, outputs, we have tables. So this is a little bit of a review from yesterday inside of today. So, what we can do is we can say in words, an output is 3 more than the input. And we get an equation, a linear equation, and we can see from a table that if I make x -1, -1 plus 3 is 2. And then y equals 2. We're going to talk more about that in a future video, so don't worry if you're confused. But 0 plus 3 is 3, 1 plus 3 is 4, 2 plus 3 is 5. So we can also make a table of the values inside of a function. Of course, you've seen them written this way. We did that a lot in the last video. And as always, if I take the points from this table and I put them on a graph, we can connect those points and get the graph of a line, a linear function. So you'll see all of these different ways of writing things at one point or another. Last video we talked about these. This video we talked a lot about the graphs. We also talked a little bit about the equations. We're going to see more of the equations and the input-output tables in a future video. Okay, wonderful. So now is a wonderful time to assess your understanding of the learning target and the success criteria. Do you know what a linear function is? And can you identify linear functions using graphs, tables, and equations? So rate yourself on a scale of 1 to 3. Remember, 1 is I don't know, 2 is I'm getting there, and 3 is, oh yeah, I understand this perfectly. Where are you? If you're a 1, make sure that you ask your teacher questions and that you go to after-school tutoring if you need it, call a friend, whatever you need. If you're a 2, start working on the homework. Know that you might need to reach out to your teacher or after-school tutoring, but sometimes homework and practice is all you need to move from a 2 to a 3. And if you're a 3, you understand it, you get the homework, you did it, you got it. Reach out to friends and see if they need help with homework or something like that. So, this is a good habit to get into anytime you learn something new. Anytime you learn something new about an instrument that you're learning to play, about a video game that you're trying to get really good at, or about science class or history or something like that. How well do I understand what I'm trying to learn? Good habit to get into. All right, of course, these are some practice problems that you can do to practice the skills you have learned in this video. I'm going to get rid of my face momentarily so that you can see all of the problems on the screen. Remember to do the homework that your teacher assigns. These are just problems that you can do. These are the problems from the textbook that match with the examples that we did in class today, or in this video. Okay, and of course, let's end our video with a launch. This is a famous saying that comes from Mahatma Gandhi, and he says, "Be the change that you wish to see in the world." So let's break it down a little bit. I'm sure you've heard this before, probably, but what does it mean? Be the change that you wish to see in the world. Well, what change do you want to see in the world? Are you grumpy that, all the relationship drama you see on TV or you see in the popular kids at school, you see, the TikTokers, them cheating on their girlfriends and relationships only last 3 months? You want that to change. You don't like that. Well, be that change. Don't cheat on your girlfriend or your boyfriend, your significant other. Don't cheat. Have meaningful relationships and encourage your friends to have meaningful relationships. Maybe you see, you watch the news and you see people are stealing things and people are hurting other people and you're like, oh my goodness, that needs to stop. That's so bad. Be that change. Don't steal things and encourage your friends not to steal things. Be nice to other people. Help other people. If you see other people hurting people and that makes you sad and you wish that would change, well, help other people and encourage other people to help each other so that we have less people hurting each other. So, anything that you want to change, if you want the world to be more patient, you think, wow, everybody just wants it now, needs it now. You want the world to be more patient yourself and encourage others to be patient as well. So, be the change. Whatever you want to change about the world, change that in you first. Start with you and help the world follow in your footsteps. So, that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day. And thanks for being here. Thanks for watching. Bye.